And we are live. Hi, everyone. Welcome to, or back to the Open Publishing Fest. My name is Dan Rudman. I am the Associate Director at Punctum Books and also one of the organizers of the Open Publishing Fest. Today, I am super excited about this demo and session because I'm joined by Joey Castillo, who is a software engineer by day, but by night he hacks hardware toward open source. And this is something that we haven't had yet at the fest. Of course, we have a lot of people talking about open source software and open access content. But I think the more we get together, the more it's increasingly important, or we realize that it's increasingly important that we think about open in expansive and comprehensive ways. And so hardware, I think, is an area where there's a lot of really exciting stuff happening. And so I will turn things over to Joey to tell you about his work creating an open source e-reader. Thanks so much, Joey, for being here.
Thanks for the introduction. All right, cool. So what is the open book? Well, it's this thing. The goal is to make an open hardware device for reading books and works in all the languages of the world. And that feels kind of like an ambitious, maybe bold statement, but I guess to get there, I kind of think we need to take a step back and look at some of the other open source software efforts, open source hardware efforts, some of the things that make a statement like that possible. Also, I'm going to say more about this at the end, but all of the open book prototypes that I'm showing, all of the design files are online. You can click on the GitHub repository link, download the design files, the BOM, and order it yourself and build it yourself. So I'll get into that at the end. But to back up, if you've ever worked around people who have been hacking on open source hardware, you're probably familiar with the Arduino. It was kind of the first, or one of the first microcontroller boards. And what is a microcontroller? It's this guy right here. It's a little chip. It's kind of like a little computer. It has all the pieces that a normal computer would have: a CPU, RAM, but it doesn't do as much. It's not as powerful. It might be the kind of computer you might have in your car to run your air conditioner or your power windows. But what's cool about putting something like that into a board like this is you can do other things with it. You can turn this Arduino board into a 3D printer or a weather station. So that's a really powerful thing. And over the years since the Arduino first came out, microcontrollers have only gotten more powerful to the point where now the microcontroller at the heart of the open book right here, it has things that has a lot more memory, a lot more abilities. It even speaks USB, so it can talk to your computer. So that's one thing that's advanced. The other thing is, because the Arduino is open source hardware, anyone can take any aspect of the design and build something on it. And one of the amazing open source hardware companies that's been doing just that is Adafruit. So if you're not familiar with Adafruit, they are I had a friend describe them to me as the essential open source hardware company. It's all women owned, no venture capital backing, and they're making they're doing serious electronics manufacturing in the heart of New York City, which I find just amazing. And Lady Ada Limor-Fried, the founder, publishes her schematics, and really most of what I learned to make the open book, I learned from looking at her schematics. So this open source hardware is they've made other open source hardware products like the Feather, and that's the first kind of stop on the way to the open book. The Feather is cool because it's like the Arduino in that it has this expandability, but it also adds battery charging. So it makes this really possible to make portable projects. And so you can take this Feather and they call them Feather wings. And so this is also from Adafruit. It's an e-paper Feather wing. So I'm just going to plug this in, and because I wrote some code to do this earlier, when I plug a battery in, it's going to display a handy little name tag here. So why is this powerful? Basically, you can make a Feather wing that does things based on the microcontroller in the Feather. And that was kind of the first prototype of the open book. So now we can get to the open book. The genesis of the open book was actually a really cool open source software project called GNU Unifont. So if you work in publishing or text, you are familiar with Unicode, which is this really ambitious effort to catalog all of the characters of all the languages of the world into one universal character encoding. So yeah, basically whether it's ancient Aramaic or modern day Cyrillic or the English language, it's all in Unicode. And Unifont was this project started in 1998 by Roman Chibora to create one unified font with every character in Unicode. So it basically becomes a universal language font. And I was enchanted when I saw Unifont. The idea of building a device that that supports universal language feels just really powerful. And the more I thought about what should it be, I realized it's got to be a book. I mean, language is such a crucial link to culture and identity, and the computing world has not always done a good job of respecting other languages and other character encodings. And yeah, so that was the genesis of the Open Book project. So I'm going to turn the camera around now so I can point it at the device. So this is the Open Book hardware as it exists right now. I've actually got two of them here. I'm going to show one of them first. This was a demo that I did a few months ago. Basically, it shows a menu system and then the beginnings of the typography. So this is in French, obviously, and I've got text rendering in bold, italic. I added some code to do word wrapping and add margins to kind of make the text more readable on the screen. And then if we go to the next page here, this is just a basic demo of some quotes. This is demonstrating the Greek language capabilities. So the language support library that I've written for this, I call it Babel. And it's basically squishing the GNU Unifont into the size where it can fit on one tiny little flash chip right here. And that chip contains languages for every language in, well, not every language in the basic multilingual plane, which is most of the languages in use today. So that's the Babel language support library. And then I'm going to go back to the main menu here. And another feature that I think is important is accessibility. So one of the things that I realized was you need to make devices that can be usable by everyone, people with different abilities. So in that sense, audiobooks were going to be like an essential use case. And so here,
The Adventures of Sherlock Holmes by Sir Arthur Conan Doyle.
This is again just a very simple demo, like trying to play a single MP3, but you can see how the hardware can support playing audio.
I have seldom heard him mention.
And then I've also done some very basic work in speech synthesis. This is based on an Adafruit library, which is itself based on another open source project. I believe it's called Speaks.
Power gauge is at 3.69 volts.
And while I don't have the demo loaded up, this headphone jack also supports a microphone preamp. So I've actually done a test before where we can get it recognizing basic voice commands. So up, down, previous, next, for someone who has limited mobility to be able to navigate this menu. So that's the demo that I did a few months ago, but it's kind of difficult to like imagine based on like these hardware features, what the actual experience of reading a book might feel like. So I have this demo, which I'm calling it MV book for minimum viable book. And basically this prototype has, these are both the same prototype. I just have a different kind of wooden case on this one. It's got an SD card. And so these files are on the SD card. And I'm using this menu system to select, let's pick this short story by Willa Cather. So it uses a different refresh to kind of make it a very fast page flipping experience. And at the bottom here, I've written a little progress bar. So as you make your way through the story, it kind of fills up from left to right. And yeah, I've read short stories in this before, and it's actually it's a really, it's a good experience. It's interesting that like our Kindles have like a full operating system and run Linux and have Wi-Fi, but ultimately the experience of reading is very simple. And if you kind of boil it down to that, you can make this piece of hardware that you can build yourself that does the task of reading. So yeah, before move on, I want to just load up this story by Tolstoy, How Much Land Does a Man Need? I read it in translation, but here it's in the original Russian. And one of the things that I found interesting working on this project was finding open or rather public domain works in different languages, and realizing that a lot of the digitization effort that's gone into public domain works has been in English language. And I had a harder time finding stories in other languages. And I think it would be really powerful for a device that like natively supports all these languages to empower people to see, like, for example, the Cherokee language was late to being encoded in Unicode, but there's all these Cherokee works that only exist online in PDFs or in image files, and encoding them in a universal text encoding format seems like a powerful thing to do. So the last prototype I'll show, this is just a kind of a tiny version that I built as an experiment. I'm calling it the Tiny Book. But it's demonstrating something that I'm really excited about, which is the Arabic language support. So Arabic is different from English in many Western languages in that it's written from right to left, but also that the character forms differ dramatically depending on where they appear in a word. So this code is not actually in. Can you hear me?
We can hear you.
Okay, great. This code actually isn't merged into the open book Arduino support library, but it is in CircuitPython, which I haven't mentioned CircuitPython yet, but this is another Adafruit project that gets the Python programming language running on these microcontrollers. And it's really powerful. It allows you to get started coding on microcontrollers really easily. And so when I started to write the Arabic shaping algorithm, I wrote it first in CircuitPython, and here it's taking Arabic text that's just standard Arabic text and connecting all of the letter forms and drawing it from right to left. So I'm really excited about that. And yeah, that's the Arabic language support. So the last thing I'm going to mention is just the power of open source to enable like makers and readers and everyone really. So remember the feather from earlier? We had this little guy. The first prototypes of the open book were built using this feather standard. And this little ePaper name tag, which I was plugging in for the name tag, it actually has all the circuitry necessary to drive an ePaper display. So one of the things, because Adafruit publishes this as an open source schematic, is I was able to take this circuitry and put it on the open book. So up here at the top right, where this ePaper display is being run, that's actually the same basic circuitry as is on this Featherwing. And so when you publish these open source schematics, it empowers people to take the starting point and build something on it. So in this case, this is another project that inspired the open book. This is the Adafruit Pi badge. And so you can see here it has these buttons, which makes it really useful as a menu experience. And so if you look on the back here, Adafruit has used a very inexpensive chip called a shift register here to enable all of these buttons. And I was able to say, wow, that's really clever, and build basically the same kind of circuit down here to enable all of the buttons on the open book. So the last thing I'll say about that is when I published the open book hardware and schematics and everything, people started to say things like, oh, I really like this, but what about a bigger screen? Or I really like this, but I think Wi-Fi would be awesome. And what I think is really great about open source hardware is A, you can download these files and build it yourself, but also B, you can download these things and add hardware that makes sense for you. Add a Wi-Fi chip, or add, if you have, one person came up to me and was like, I love this. I love the idea of having a foot pedal because I want to use it for turning pages of sheet music. And A, you could just take the open book as it exists and plug a foot pedal into the side. But B, if you wanted to design something that was more suited for sheet music on the stage, you could build that device and take what I've done as a starting point. So I just think open source hardware is this really empowering thing. And whether it's accessible technologies or any of these things. So in terms of how to get it, right now you can go to the repository, download the files. There's this really awesome company called OSH Park out of Portland, I believe, Oregon. And they'll, like, a few years ago, you had to send your PCB designs off overseas to get manufactured, and you'd get them back weeks later. Now, OSH Park will sell you or will make a board of your own design about this size, a feather size. It's $9 for 3, and you'll get it in 2 weeks. It's just this incredibly empowering time if you want to start getting started on making things and hacking on hardware. So that's, I guess, the revelation to me, and what I'm really excited to share with people. The idea that the world is this makeable, hackable place, and you don't have to accept the gadgets that were built for you. You can build your own gadget. You can build something that makes sense for you. You don't have to accept the Kindle that reads your reading habits back, or the iPad that offers more distractions than focus. You can make a device that makes sense for you. So that's roughly the demo that I wanted to give. And then I'm not sure if Dan had any questions or if anyone had any thoughts or questions on YouTube.
Thank you so much. That's so awesome. Lots of questions. On YouTube, I think mostly people are expressing their excitement. So let me just ask you a few questions generally about, well, first, I'm just interested in how you got into this world in the first place. How did this all begin for you?
I had an interest in electronics as a kid, but I honestly could never really get my head around it or understand it. And so I ended up getting into software. But really it is like recently, it feels like the world of hardware has just, like, at least in terms of like the hobbyist world, it feels like things have accelerated so much, thanks in large part to companies like Adafruit and Oshpark and other people doing open source hardware work. I'm going to miss people if I try to start listing them out, but yeah, like, there's just such a wealth of knowledge out there and such a wealth of like tutorials. Like I'll give you an example. The first prototype of the open book looked like this. It was just kind of a mess of wires and some buttons that I soldered together. But in looking on like YouTube and like Spark Fun and Adafruit both had like tutorials and guides and things that taught me like surface mount soldering, to where I could actually make hardware that looked more like this, where it's like all soldered down to the surface and a lot cleaner and more well designed. So yeah, I think it's just it's always been an interest, but it's just now that I think I've been able to, like, again, building on the amazing work of others, start to learn more and do it myself.
So it sounds like what you describe is just a very collaborative community. How have you, how do people generally interact and meet each other and get into this world, if for people out there who are interested?
Well, I feel like I'm incredibly new to this world, and I feel almost like I shouldn't be the one giving this presentation. Like, there's so many people who have done more than me. But the Adafruit has a Discord channel, and if you just Google Adafruit Discord, you'll find it. And I've been able to reach out. Like Lady Ada once, like I asked a question about the flash chip that I was working on and whether they'd done something similar, and Lady Ada herself like just responded to me in the Discord, which is like amazing. And like Scott within the Circuit Python team, like it's just a really welcoming community of people. Also, I just like at one point when I was first working on the prototype, I just asked Twitter generally, like, I'm trying to build this thing and it's not working. And someone I didn't even know named Tom Fleet, who's a really nice guy, and like he reached out to me, like looking at my schematic, I think it might be this, and it totally was. And that's the reason that the first prototype worked, is because the reason the first prototype worked is because he was able to help me debug the board. And so, yeah, the community is out there, and it's awesome.
It's so cool to know that you know, we're so stuck in sort of competitive mindsets for hardware, and that we have to be like an Apple person or a Google, you know, that there are these more collaborative spaces. Can you talk to me a little bit about your relationship with books, and why, you know, since you are new to this, have selected a book as one of your first major projects?
I mean, I've always been an avid reader. I think in terms of this project, I think it was the Unifont was what inspired me to get working on a book. It was just, what is the application for a universal language device? A book just it just seems like intuitively it makes sense. But no, in terms of reading, like I'm part of a book club in New York, which sadly isn't able to meet right now. And yeah, I love reading, and I think this project just seemed like a natural fit.
So, am I right to assume that, you know, most of the books that you've been testing this out with, they've been public domain books? That's how you've been.
Yeah, in fact, I haven't really been testing with novels per se. I've been testing with short stories, all in the public domain, mainly because at this point the hardware doesn't, or the software I've written doesn't save your place. It's a feature that I can implement that feature. I just haven't made the time for it, sadly. But once that's done, it'll be more useful for reading novels. But mostly I've been reading short stories on it. The one exception was the first story that I read on it was actually not public domain. It was I copied the text off of the New Yorker's website. It's Brokeback Mountain by Annie Proulx. I figured it's no different than putting it in my Instapaper and reading it there, but I'm not distributing it or anything. But it's just a short story that I loved deeply, and I remember like curling up with this prototype. It's just a mess of wires reading in my bed, and it was kind of magical. The device just kind of got out of the way, and I was reading and feeling things, and it was yeah.
That's really wonderful to hear, I think, because that's a lot of in my experience with e-readers, the need for them to get out of the way a little bit is something that is missing, I think. You know, there's so much branding, and you're locked into certain DRM and certain software that you feel, you're constantly aware of that noise in the background, and you're not able to just get into the material that you're reading. So that's wonderful to hear that that's actually possible, I guess.
Well, that's one other thing. I definitely, I made the choice. Well, I mean, a lot of the optimizations that I've chosen for the open book, I've chosen to optimize for cost, because I want this to be really accessible to people. I want it to be like, if you're going to build something yourself, you shouldn't have to like buy a like $80 screen that you like worry about breaking or not building it right. It should be accessible. And so some of the compromises were like a smaller screen because it's less expensive, and definitely like not having Wi-Fi was another design compromise. But there are actually Wi-Fi chips that are like affordable in this price range, I think, like, or Wi-Fi modules, I should say. But I like the idea that it doesn't have Wi-Fi by default. That like you don't, like, a book doesn't necessarily need to be connected to the internet. That doesn't seem like a part of the essential use case for a reading device. And I think it's funny that in this like rush to the Internet of Things, and putting the internet in your refrigerator and the internet in everything, I'm kind of like, I don't know, like it's a bit quixotic, maybe, just like tilting the other direction, being like, no, disconnected devices.
Well, I think what you were saying toward the end of the demo, the ability to focus on what you're doing, and to not feel as though everything you do is being monitored for data mining. It really does make a difference. It brings a different kind of peace of mind that people don't realize until they've started to really operate in that space. We're so used to it for so long, this kind of surveillance capitalism situation that we're in. So just to say to you also about the accessibility issue. So we at Punctum Books, we publish all of our work open access. And what that essentially means is that all of our books are available online to read for free. And there are challenges with that, because our idea is that we want knowledge to be public and to be available for everyone. But to say that it's online for free is not necessarily as accessible as we want to be. And so this is where your work is really meaningful to us, because if there is a way that you're not dependent on a several $100 computer, that you don't need to have a Wi-Fi connection to be able to access these books, it really changes the landscape as to who can read and who this knowledge is for.
Totally. And I think it's interesting how like our idea of what is magical technology shifts so quickly. But as soon as we have connected devices, suddenly like the connection to the internet becomes a magical thing. But like this SD card, which like my first computer had a 400 megabyte hard drive. This little thing that's smaller than my thumbnail contains 8,000 megabytes. Like it's kind of magical to think that you could distribute work in that way and not worry about like bandwidth or connectivity. But like this is revolutionary, and we forget about it because we're all talking about putting things online. And I'm not sure if this is making sense, but that's one aspect of it that I find really interesting. Just the idea that like what technologies exist, what can we leverage to make things more accessible?
Oh, no, I completely agree. And I think this is something that we've been talking about in a number of sessions, is that we are advancing so rapidly in technology. And maybe advancing is not the right word, where our technology is changing so quickly, and we have obsolescence occurring so quickly that we don't even have opportunity to understand the implications of the technology that we're developing. And so, something that was developed, half a decade ago, doesn't have time to realize its potential, because then we've all moved on to, the next magical device. And so really taking stock of what we have and thinking about ways in which we can leverage that to create the kind of world that we want, a world that is more accessible, that does share knowledge more freely, is really important. And we need to, and it's good that, there are people who are not losing sight of that just for the next shiny thing.
There's this Frank Lloyd Wright quote that I printed out, and it kind of was one of my words to live by like the last few years, but it's less is only more where more is no good. And it feels like we've definitely reached a point in our technology where more is no good. More connectivity, I don't feel like is good. And like in so many ways, I find it kind of liberating to work in more resource constrained kind of situations because it causes you to focus more. Like, this is not related to the open book, but one of my favorite hardware projects right now, I'm working with this, it's kind of a similar chip to what's in the open book. This open book is a SAM D51, and this is called a SAM D11. It's kind of like their smaller version of it. It's got, a tiny amount of memory, a tiny amount of RAM. But if you like are really specific and careful about what code you decide to write and what you put there, you can make really useful things. Like one is like monitoring moisture and soil moisture in the garden, and one I'm trying to build one that's like a little candle like lantern for my mom. It's like with an accelerometer, so if you pick it up, it'll like light up. But the idea is you don't necessarily need Linux operating system to make a lantern. You can do more with less because there's no need to put like the internet into a candle in my mom's garden. That's what I'm trying to get at.
No, I totally agree. Actually, since you mentioned that, can you talk a little bit about your other open hardware projects, just so people get a sense of what's being dreamed up and what's possible?
Well, first of all, most of what I'm building right now is just for me to learn, and I'm last month, my big project was because of the coronavirus. I wanted to have temperature monitoring on my body, so I wanted to build a baseball cap with a temperature sensor in it. So I called it the it was first was a temperature hat, now it's a sensor cap. But yeah, it's just a little kind of a modular system for plugging different kinds of sensors into a small board and then logging that data, and it kind of lights up a red light if it thinks your temperature is too high. So that's one, and then there's this like sensor candle kind of project that I'm working on. But yeah, I mean, mostly though, I'm kind of building these things just to learn and teach myself because I do have a lot still to learn. And I mean, I'm sharing them all like on my GitHub, like there you can download the things and like as I'm working through these things, kind of build along at home. But I'm less excited about like the idea of taking one of these things and building 100 of them and sending them to 100 people. I'm more excited about the idea of 100 people finding this and thinking it's interesting and building one themselves. That seems like the empowering thing. The other thing is commercial. This is more like, well, let's just share knowledge and hack on each other's stuff.
We've been talking about that as well. That's come up a lot in other sessions. The idea that we don't want to flatten out the possibilities of expression. So we need to think about ways of working together, but not necessarily getting stuck into, well, there's an issue of like monopolizing a certain sector, and then the issue of kind of who gets to have a voice here. And if we allow for more possibilities and more voices to come through, the hope is, a lot of times people feel as though we're kind of competing for limited resources. But I think if we can continue in this way, we're actually creating more possible resources for people and more knowledge to share, and more innovation in a lot of different directions.
And if you're talking about that, I think Adafruit is like, you should send like adafruit.com in the chat as well, because like they are doing exactly that kind of thing. And I think it's really powerful. Like for my birthday, I got my sister it's a really clever board that Lady Ada designed called the Circuit Playground. And it's just got like all these sensors and colored lights and all of these tutorials based around like, what can you do if you can sense like temperature and light, or like if you want to like plug a little speaker so you can make it beep, or buttons, and just all of these like things that kind of empower people to take this device and be like, what do I see in my room or in my world that I want to code with or build on or build for? And like whether it's like it started out with Arduino, but now like CircuitPython makes that easier. And then there's this technology called Microsoft Make Code, where you can kind of just drag and drop blocks of code to do really useful things. And anyway, I got my sister one of these for her birthday, and we were like, the soil sensor kind of started its life as on the kitchen table with like little nails in a basil plant. So I guess she was like measuring the resistance of the soil. And it's really awesome to be able to say like, I am empowered to write code for the world around me. And yeah, like I think that's so much of what I think this movement is about.
It's really awesome to see that people can participate in this way. It's not just a matter of consuming; it's a matter of really being part of this world. So it's super cool. But we have time. But one other thing. Speaking of expanding participation in the world, I wanted to just come back to your Babel chip and the issue of languages. this is another thing with technology advancing at a rapid pace. English became, the primary language of the internet, and that really is exclusionary. Can you talk a little bit about your experiences in incorporating different languages with your project?
Sure, and actually, I can talk about it in terms of other languages and also other cultures in general. One of my other projects is this Apple Watch app called Better Day, and it's just a little calendar that lets you browse through months. And one of my goals for it, I'll get to language in a moment, I promise. One of my goals for it was to support all of the calendar systems of the world and all of for the Islamic calendar or the Hebrew calendar. And as I worked on this project, I realized there are so many nooks and crannies and edge cases around calendars. Like the Hebrew calendar has 13 months in some years. And the Islamic calendar wraps around based on the moon. And there was this one issue a few years ago where, because the crescent moon wasn't sighted in Mecca on the correct date, they actually shifted the entire month back by a day. And I had to add a feature where someone could change the month because the moon wasn't sighted. And so it just kind of shows you that if your idea of what is a calendar is limited to 12 months starting on January 1st, you're missing out on so much of the diversity of calendar systems in the world. And so similarly with languages, when I was working on the Babel chip, it's yes, Unifont has glyphs for all the languages of the world, but then you run into things like Arabic. Arabic script is encoded as all these code points, but they're not actually, the code point doesn't actually tell you how to connect. So you have to write software that connects the code points properly. And the vowels are written above and below the line. So now your code has to avoid those vowels when you're figuring out what letter to encode. Or ligatures, one in Arabic, if you have the letter lam followed by the aleph, they have the lam aleph as a ligature, and that's the only way that those two letters are ever written together. So it's really fascinating, and I feel it gives you a deeper respect for just again, most of the people in the world don't speak your language, and they are. It's as a side note, it just reminds me of this old blog post I saw from the makers of some library software, and they described how most of their sales came from Europe and non-English speaking countries, and they wrote, "That's real money. Those sales, you're going to want that." But even if you're doing open source hardware and not trying to make money off of it, the idea that showing someone your language is respected, your language is a first-class citizen in this device or the software that I'm writing, I think that, yeah, it's powerful. And you're right, English became the de facto language because we were trying to build computers to run teletype machines that were, going to missile silos in the Cold War. And then we ended up giving everyone the internet, and that blind spot persisted into the present day. So yeah, it's on us to do better.
Yeah, it's very comforting to know that it's perhaps not too late, that we can, rethink that. But I think your discussion of the calendar is such an important point, because it's not just a matter of having a language and, being able to communicate across languages with something like a machine translation algorithm that allows you to do that. But it's really about the inclusion of entire worldviews, where there's so much more than our perspective on the ways in which the months work, for example, like you said. And so we do really risk flattening out and missing out on one another unless we really can do this. So it's really awesome to see. And it's awesome to see, that these languages can run simultaneously, that it's not a matter of switching all the way over from one language to another. So that's that. Yeah, please go ahead.
But that's really interesting, because the idea that our assumption would be that you have to switch from one language to another, it's kind of funny. A computer has no idea the difference between the number, there's 128 characters in ASCII, which is the bare minimum for printing stuff, and there's 65,000 code points in the basic multilingual plane. The numbers 128 and 65,000 aren't that different from the perspective of a computer. So it's just that we decided to make ASCII the default that makes us assume that we have to switch into a different language mode or a different code page. But if you, Babel, for example, right now it's mostly the basic multilingual plane. I'm working on the supplemental planes, which has more Chinese, Japanese, Korean, and more ancient languages. But ultimately, the goal is to have every code point, whether it's ancient Aramaic or the English letter E, to be treated exactly the same way in the code, so that when you have this page here, whether it's just, like right now, displaying a Cyrillic letter or an English letter, it's the exact same code path. There's no different code path for different languages. And yeah, it's totally possible. And in fairness, like I should say, like the mainstream computing world, like Linux and like Mac OS, like are actually great at this now. Like this is not like I'm inventing this for the first time. What's interesting here is that it's on a microcontroller where it's like a really small resource constrained environment. And you might think, oh, because you only have like less than a megabyte of RAM, you wouldn't be able to do this. But if you if you focus and you make the choices about what you want to like, where do you want to put effort and where do you want to like spend storage, you can do that. So
yeah, that's a really interesting point. That is a choice. We kind of we take all these things as a default, but they've just been conscious choices that we can rethink or build something else. It's very easy to feel like we're stuck in our certain systems right now. Well, it's really awesome to speak with you and to learn more about the open book. And so if people want to follow along with you, I know you have a GitHub repository that we've shared. There's also Patreon that has blog post updates.
Yes, and the Hackaday page. I didn't send the Hackaday page, but there's if you Google Hackaday, the open book, that's like the Hackaday project page, and that's where a lot of I'm going to try to be better about updating things more there as well.
Well, I'll be sure to put that in the description of the live stream or the recorded stream as well. Yeah, any last thoughts or anything else you would like to let us know about your work?
No, I'm just really stoked to share it. And like I said, it's buildable right now. Like the final version of the PCB is version A105, and I'm going to try to get some of the bare PCBs ordered and put them in a Tindy store. I guess there is the ebook wing, which is this blue board. This circuit board is actually available in the Tindy store. And the thing about it is it doesn't actually have the microcontroller. You need to plug a feather into the back to actually make it run. But I figured I would put that one up first because it's a little bit easier to build. There's fewer parts, and it's like they're easier to solder parts. There's a couple of finicky bits on the back of the open book. So that's that. And then yeah, the open book did win a contest in January. Like Adafruit is going to try to make a small run of the boards, but unfortunately with the pandemic, all the plans got put on pause. So I'm hopeful that'll happen in the future. But in the meantime, again, like I'm really stoked about the idea of people doing it themselves, because that's I think the real magic.
Yeah, absolutely. Well, it's really wonderful of you to come here and to tell us all about your work. And I think that's another way of keeping it open, of sharing the process and the thought behind all of this, so that people can have the freedom to kind of pick it up and take it in whatever direction they'd like. So thank you so much, Joey Castillo.
Thank you.
Yeah, I really appreciate talking to you, and I'm glad to be in touch, and I hope to continue learning from your work.
Thanks so much.